Hey everyone, welcome to my new Asteroids tutorial for the Godot Engine 3.1. This series is meant to be an introduction to the engine. Whether you're new to game development or you just want to learn how the engine works, this should be a good fit for you. We'll be using Godot's GD script for this tutorial, which is very easy to learn, very integrated into the engine, and if you have experience with Python, then it should be really easy to pick up. So like I said, we'll be recreating the classic game Asteroids. In this video, we will have a ship that can turn, accelerate, and wrap around the screen when on the edge. In the next tutorial, we'll have it be able to shoot asteroids that will split into smaller asteroids. So I'll be explaining the Godot Editor as thoroughly as I can. As for programming with GD script itself, I will explain what each important line does, but I won't be going too into things like what a variable or a function is. I do expect that you have some experience with programming before hopping into this. So when you open the engine, you'll be met with this screen. On the right hand pane, select New Project, type in a name, in this case Asteroids Tutorial, and hit Create Folder and create an edit. Once you have created the project, the main view will have shown up, but first you navigate to that new folder you just made, or just go to the file system, right click here, and do Open in File Manager. We need 3 new folders: Scenes, which I'll explain in a bit, Scripts, and Sprites, which is going to be all of our image files. So in the description, I have an image file that you're going to have to download and put it into the Sprites folder. It is this little 2-frame animation for a ship. We won't be doing any animations today. We'll get to that in a future video, probably the second or third. But yeah, just stick it in your Sprites folder and they should all show up right here. So first thing we have to do is change the display settings. So if you head up here to Project and Project Settings, here are all of Godot's project settings. A lot of the game settings can be changed in this menu, like controls, which we won't bother with because they have preset controls that we could use, localization, bunch of stuff. But we're gonna, in the General tab, scroll down to Window under Display, and we will set some of these things. So width is going to be 320 and height is going to be 180. So these are just the actual dimensions of the game's window. But we're going to want it to be a little higher because our monitors are bigger. So we're going to set test width to 1280 and test height to 720 and set stretch mode to 2D and aspect to keep. So the actual game, the actual game's logic is going to be a lot smaller size at 320 by 180, but we're just going to stretch it to this 1280 by 720 window so that we could see it a lot more easily. Okay, sweet. So one of the things that sets Godot apart from other engines is its node and scene system. Basically, just about every component in your game is going to be a node. There are many types of nodes here. Some pertain to 2D games, some are for 3D games, and there are a lot for UI stuff. So a node might be a sprite, which just shows an image on the screen. There are animation players, which let you animate any of the properties of other nodes, which we're mostly going to be using just to make the sprites move. And yeah, so every node could be nested under another node to create a scene. So all of your objects are going to be scenes. So let's say if you want to make an enemy scene might consist of a sprite node for its visuals, an area 2D node for its hitbox, and an animation player for its animation. If you're new to this format, things are going to be a little confusing, but once you understand the node and scene system is usually when Godot starts to click for people. In this tutorial, I'll be explaining in depth just a couple of nodes and their properties. And there will be a link in the description to the Godot's documentation, and you could look into more there. So we're going to start with the player scene, or the player object. First, let's click 2D up here to enter the 2D view. This is going to be a 2D tutorial. This is the 320 by 180 window that we configured just a second ago. And over here is the scene tree. So hit custom node and search for area 2D. An area 2D node is used to detect if any other area 2D nodes or physics bodies are overlapping it. Our player is going to be an area 2D node, so it could detect if it collided with an asteroid, which is also going to be an area 2D, and reset the game. We're going to be covering the actual area 2D overlap stuff later. Right now, we just want the player to be able to move around, so don't worry about this little yellow triangle that says there's no shape. We'll configure that in a bit. But rename the area 2D player, and then hit save scene to the scenes folder, and hit save. So, okay. Now, here's the area 2D is just a node right now, right? If we right click it and do add child node, this is when it becomes a scene, because now it has something else nested under it that creates one object. So search for sprite. This is going to be the actual image for the sprite. On the right we have the inspector, and this is all the different stuff we could change about the node. Every node has different properties here that could be changed. What we're going to do right now is take the texture, hit load, and just select that ship.png that we downloaded earlier. Now it's a little blurry right here, and there's two ships when we only need one. So set the V frames to 2. That's for sprite sheets. If you have a big sprite sheet with a bunch of frames, V frames is vertical frames, H frames is horizontal frames. And then this frame option down here is what lets us change to the flying animation or the idle animation. But right now we just want the idle animation. To make it not blurry and be pixel perfect, we go to import, go to the file system and select the ship, do preset 2D pixel and re-import it, and then you could set as default for texture so we don't have to do this in the future. Okay, so we got a little ship here. Has a nice little sprite texture that I whipped up in a few minutes, and it's pixelated and not blurry. So now we can get to the actual scripting part. So select player, make sure you're not selecting sprite, and hit this icon up here. So this adds a script to the node or the scene. So template will do empty, and we'll save this in our scripts folder as player.gd, and then just hit create. So now with the script editor open, we have just a line that says extends area 2D. You could hold shift and F1 over this to see all of the things that an area 2D is able to use, and all of it inherits from all of these things, which have more functions. But just follow along with what I put. You don't have to worry about all that right now. What we have to do right now is start by allowing the player to turn left or right. So we'll have a constant called turn speed. It's not going to be a variable because we don't need it to change, and that's going to be set to 180. That's going to be the actual speed that the ship will turn when you press left or right. And then we're going to create a process function. So the process function is called every single frame. And so every single frame, we are going to check if action input is action pressed, not just pressed, make sure you do pressed, and do UI left. So you saw earlier, they have all of these preset actions in the input map. UI left is going to check if the arrow key is left, or if a D-pad is pressed, if you have a controller connected. We want to use is action pressed and not just pressed, because that'll only check if you just pressed the button, so only once when you press the button. Since this is in the process function and we want it to be turning every time, like every single frame that you have it held down, we're going to use pressed. So inside the if statement, rotation degrees, that is a property that's part of this node down here, rotation degrees. We're going to take the rotation degrees and subtract turn speed times delta. So you do that subtract equals sign, so you could just subtract it from there instead of have to do equals rotation degrees minus blah blah blah. So we have to multiply it by delta so that we have to multiply it by delta in order to make sure everything is timed correctly regardless of frame drops. If you just search up delta timing, a Wikipedia page should show up that explains why we have to do this, but basically regardless of lag drops, it'll always turn the same speed. Okay, let's just do the same thing for is action pressed UI right rotation degrees plus equals turn speed times delta. So I'm going to hit Control S to save. Before we could test this, we have to create the main scene for our project. So that's just going to be the scene that opens up when the project is run. So up here, let's do new scene, go back to the 2D pane, and let's make a 2D scene. I'm just going to call it main, and then you could instance child scene and select our player scene. So let's move our player scene just to the middle of the scene, save this to our scenes folder as main, and then hit run up here. It's going to ask you to select a main scene and just select the one we just saved. So now the game should open up and our player is in the middle of the screen, and if we hold left, he'll turn to the left. If we hold right, he'll turn to the right. Cool. So that works. Let's go back to our player script. And now we are going to make it move forward. Now we don't want it to just move forward a bit and then stop when we let go of the button. We want it to accelerate when we're holding it and decelerate when we're not holding it. So we need 3 new constants. Move speed, this is going to be the max speed it can move. Acceleration, which is going to be what percentage of the move speed it'll go every frame. Well, not exactly. I'll explain a bit in a second. And this is going to be deceleration. And then we need a variable called motion, which is going to be a vector2 0 0. Okay, so motion is a vector2. It's gonna hold the direction that the ship is actually going, and then we're going to have another variable that will be where we are trying to go based off of our rotation degrees. A vector2 is basically if the player, let's just say this is vector2 0 0. Vector2 1 0 is going to be 1 pixel to the right and 0 pixels up or down, and it'll be trying to go to the right. I'll put a link to how vectored math works if you haven't used this. So now we need a variable inside the process function. It doesn't have to be outside, because this is only going to be used within the process function, called move direction, and that'll equal vector2 1 0, so it's facing to the right, but then we will rotate it by our rotation degrees, or not rotation degrees, just rotation. So That's going to take just a regular vector 2 that's facing to the right, and then adjust it so that it's according to where the sprite, or where the area 2D is facing. So now let's do our acceleration code. If input is action pressed UI up, we're going to take motion up here and linear interpolate it, motion.linear interpolate, and then the first argument will be mover, second argument will be acceleration. So if you don't know what lerping is, linear interpolation, basically we're going to smoothly animate motion, which is where we're trying to go, based off of, motion is where we are going, based off of move direction, which is where we're trying to go. And we're going to do it by the acceleration value that we defined up there. That's gonna make sense in a second. Else, we're gonna do the same thing, except instead of going towards move direction, it's going to go towards vector 2, 0, 0, or stillness, and it's gonna use our deceleration constant. Oh, my bad. Okay. So every frame that the up key is pressed, it is going to go, imagine motion as the starting point and move direction as the end point. It's going to go this percentage of the way there every single frame, so 5%. And then every frame that UI up is not being pressed, it is going to go from motion to vector 2, 0, 0, or stillness, by the deceleration. So it's going to go 1% of the distance every single frame. So yeah. Then we're just going to use this value by adding it to our position. Motion times move speed times delta. So yeah, hopefully that makes sense, the difference between move direction and motion. Move direction is the direction we're facing and where we want to go. Motion is, because of all these values, isn't necessarily going to be always directly straightforward. So let's run the game now. If we hold up, we'll move forward. If we let go, then we'll decelerate. And this works regardless of the direction we're turning. If we're already moving in one direction, we will continue to move in that direction. The last thing we have to do for this tutorial is add screen wrapping. So that's going to be what allows the ship to go off of one end of the screen and pop out of the other. Because right now, if you just go up, you could just keep going up forever. What we're gonna need right now are two new variables: screen size and screen buffer. And buffer will equal 8, and screen size we have to set inside of a ready function. So the screen size starts off on undefined, and we have to do it after the rest of the game has initialized. So in the ready function, this is what happens after all of the node with the scripts parents are already ready, and then but before anything in the process function starts. So we'll just set screen size to get viewport rectangle dot size. That's going to equal the same thing as we set in the display settings, so 320 by 180. So screen buffer, this is going to be how far the ship could move off the screen before it reappears on the other side. We're technically not making true screen wrapping, because if you're like all the way at the edge of the screen, you won't see yourself on one end and the other end have the rest of you. It's just gonna wait until you're fully off screen and then put you on the other side. So it's not real screen wrapping, but it gets the idea across. So under our position stuff, we're going to set position.x to wrap f. This is wrap float position.x negative screen buffer, and then screen size.x plus screen buffer. Let me zoom out a little bit. So, okay, this wrap f function, basically, let's say we did wrap f, I don't know, position.y, and then negative 20 and 20. Basically, if position.y ever goes below negative 20, it'll set it to 20. And if it ever goes above 20, it'll set it to negative 20. Or whatever the numbers are. If it's below negative 20, it'll go to 25. Or above 25, it'll go to negative 18. Anything like that. So we're going to do that with the position.x. We're going to take position.x. And if it's past negative 8, then it'll be set to whatever the width of the screen size is plus 8. So let me demonstrate that real quick. If it was set to 0 and we move off the screen, then it'll just show up off the screen, but instead the ship has to go fully off screen, so that's the screen buffer, and then it shows up on the other end. So that's just for the horizontal position. Let's do it for y. .y equals wrap f position.y negative screen buffer screen size y plus screen buffer. So that should work for both ends. And if we go up, then we'll show up at the other end. If we go down, we'll show up on that end, and it works for everything. Cool. Just as a demonstration, if we set the screen buffer to 0, or just made it so that it's, if we go past 0 or 320, because this is negative 8 and 328 when the screen buffer is 8, then the ship will kind of teleport halfway through it's supposed to. Bam. So we don't want that, and that's why we use the screen buffer. So yeah, that's it. That's everything for part 1 of this tutorial. Part 2, we'll start getting into the asteroids and the bullets that the ship will be able to shoot. If you want to download this project, you could go to the text tutorial version in the description. It also has all of the code commented out if you want to look at more explanations of it. Excuse me. But yeah, that's all I got for this tutorial. I hope that it was helpful, and I'll see you soon.